whenever you're ready.
Okay, today we're going to do a brief demonstration on running a compression test. Now the compression test we're going to do on this particular vehicle is really straightforward because this is an old car. There's very little in the way, it's a very easy process. Modern vehicles, you're probably going to have to dig through a whole lot more stuff to get to the plugs in order to do a compression test. Otherwise, the principles behind doing the compression test are the same. Reason we're going to do a compression test is basically just to see if we can confirm what kind of condition the engine might be in. Now, when you're doing a compression test, keep in mind that if you have a specification, the specification for the amount of pressure that you should see when the engine is cranking is going to be affected by things like vehicle altitude, in other words, where the car is at, and also the cranking speed of the engine. Make sure that when you're doing a compression test, the batteries are fully charged and in good condition. If they're not, you're going to get a false reading. If you need to put the vehicle on a charger before doing a compression test, do that first. Make sure those batteries are going to allow the engine to crank at the desired RPM. Generally, you want to see at least 140, 150 RPM cranking. Altitude needs to be taken into effect because the higher you are in altitude, the less air density there is. The lower the amount of air mass entering the engine, the lower the compression test result you're going to see. At a high enough altitude, you might actually see a difference approaching 20%. So, in other words, if I've got a vehicle that the compression is supposed to be at about 150 pounds at sea level, at a high elevation like in Denver, Colorado, we might actually see almost a 20% reduction in the cranking pressure. That would be roughly 30 pounds less, or about 120 pounds at altitude. So if you see a reading at altitude that's quite a bit lower than the specification for sea level, don't get alarmed. In that situation, the best thing you can do is check all of the cylinders on the engine. When you go through and you look at the compression on each cylinder, then compare the compression values. Those values should be within roughly 10%. If you've got a vehicle that you've got one cylinder at 120 pounds, to maintain a 10% range, you really don't want to see much less than 110 pounds or more than 130 pounds on any given cylinder. All right, the tools we need to do this are right here on this particular vehicle. For many modern vehicles, you're going to need a whole bunch more. I need at least ratchets, a spark plug socket, maybe an extension, spark plug wire pliers, and a compression gauge. As long as I have these fundamental tools, anything else that you need is going to be in order to gain access to the spark plugs. Anytime you're dealing with the spark plug wire, it's a good idea to use a pair of pliers to remove the wire. In order to use these pliers, take the plier, get down on the spark plug boot, surround the boot, twist the wire while pulling. Okay? Remove the wire. Some are going to come off easier than others. Again, twist and pull. If we were to just grab the wire back here or right here, there's a very real chance that we're going to damage the wire, leaving the center terminal on the spark plug. We don't want to do that. Once your plug wire is off, then we're going to go ahead and remove the spark plug. And you'll notice that this particular spark plug socket has actually been cut down quite a bit. The reason it's been cut down is so that it's got good clearance for these headers. You may find in your toolbox that you're going to need to have many different spark plug sockets, each one of them of a different length, in order to allow you to gain access to spark plugs in tight environments. Once the spark plug is out, try not to drop it. Set it to the side. Take the compression gauge, find an adapter that's going to work well in this particular cylinder head. This particular adapter right here is the one I need. Notice there's a Schrader valve in the end of this thing. If you do not have a Schrader valve in the end of your adapter, you will not get an accurate result. Thread this hose into the cylinder head. We want to run it down until it's just snug. Make sure that you don't use too long of an adapter. If you use a really long adapter in the wrong vehicle, it's possible that you could have an adapter that interferes with the valve movement or possibly even the piston. It's unlikely you're going to have piston to adapter interference, but it can happen. I'm going to snap the fitting on the gauge to the adapter hose. Now my gauge is in place. I need to remove this air cleaner. And then I need to take this vehicle and put it at wide open throttle. If the vehicle's carburetors or throttle bodies are at wide open throttle, you're going to find that you're going to get a much more accurate result. If it's not at wide open throttle, the throttle angle itself can actually interfere with the reading you get. In order to hold this at wide open throttle, I'm just going to reposition these springs and put them on the throttle linkage there. Okay. The other thing that we need to do is we need to disable the vehicle so the engine will not run when we crank it. So on this one, I'm going to disconnect the coil secondary wire. Okay. Now, there's no way for high voltage current to get to the distributor. If there's no current at the distributor, I'm not going to get current at the plugs. The engine will not run.